Hello, let's talk about standard alignment of plastic frames and cover all the steps involved. Let's get started.
Why do we do standard alignment of plastic frames? First of all, it provides practice and groundwork for frame adjusting and customized fitting. A frame in standard alignment has been adjusted to impersonal standards that are independent of the face characteristics it is to be fitted to. This serves as a uniform and consistent starting point.
Learning objectives. Upon completion of this module, students will be able to list the steps required in standard alignment of plastic frames, describe the features of a frame in bench alignment or standard alignment, and manipulate a frame to correct defects and achieve standard alignment.
Standard alignment of plastic frames requires that the frame is heated to prevent breakage when aligning or adjusting. Different materials require varying amounts of heat to make the frame pliable. Heated glass beads or hot air blowers can be used. Heating the frame. Plastic frames require heat in order to manipulate them. Air blowers can be used and are quite handy because they heat only the part of the frame being worked on. Be sure to constantly move and rotate the frame to ensure even heating. Check the material, as some materials take more heat than others and some can take no heat at all. If you're using glass beads, make sure you stir them first. Make sure the material and the lenses can be subjected to heat and keep moving the frame parallel to the surface of the beads. Attempt to heat only the portion of the frame you are going to work on. This is an example of a frame that has been overheated, resulting in bubbling of the plastic on the upper rim. Horizontal alignment is the first step of standard alignment of plastic frames. The correct alignment is when viewing the frame from the front. Use a ruler or straight edge and place it across the back of the frame at the top of the pads. If there are no pads, look for a reference point on the bridge. Both end pieces should be equal distance from the ruler when the ruler is running straight across. Experienced opticians often have the ability to recognize this error without using a ruler. The first defect to look for in horizontal alignment is the rotated lens, which appears as the lens shape being uneven, raised nasally or temporally. The solution to this is to heat the frame and correct with the lens rotating pliers until the lenses align equally. The second defect we look for when doing horizontal alignment is a skewed bridge, and this appears as one lens sitting higher. Without the lens rotated, the bridge is actually slanted. The solution to this is heating the bridge until it's soft, grasp the front and force the eye wires in opposite directions until the bridge is straight and the lenses are aligned horizontally. On this slide, we're looking at what a skewed bridge looks like on the patient. One lens appears higher without the lens being rotated. It's the bridge that is slanted. Notice the line across the top is straight, but the bridge is not. This is a metal frame, but it's a good illustration of what a skewed bridge looks like. Vertical alignment. The correct alignment, when viewed from above using a straight edge or a ruler along the inside of the frame front, there is no face form with eye wires touching at the 4 points. With face form, eye wires will touch temporally and are equal distance nasally. Viewed from the side, the eye wires will be coplanar and parallel. When looking at face form, the defect can be an excessive face form, both positive or negative. View the frame from the top. Too much face form will have the eye wire at the temporal area with excessive distance from the ruler. Too much negative face form will have the eye wire at the nasal area being an excessive distance from the ruler. The solution is to heat the bridge until soft and alter or bend appropriately so the lenses align. This slide shows an example of a frame with negative face form. The next defect that you can have in vertical alignment is Xing. View the frame from the side. The frame front is twisted at the bridge, causing temples to be out of line. This is called Xing because the eye wires form an X when viewed from the side. The solution is to heat the bridge until soft, grasp the eye wires, and rotate the hands in opposite directions until the lenses are aligned and parallel. Here we see an example of Xing when looking at the side of the frame as shown in figure 8-10, and on the right hand side you can see the hands grasping the frame and twisting it to correct Xing. The third defect possible when looking at vertical alignment of the frame is variant planes. View the frame from the top. The lens planes are parallel, but one is positioned ahead of the other. The bridge appears bent. The solution to this is to heat the bridge until soft. Push and pull appropriate eye wires to straighten the bridge while keeping parallel. The next error is open temple angle. The correct alignment when viewed from the top has the temples parallel and extending from the end pieces at 90 to 95 degrees. The temple shafts are straight and the angles are both symmetrical. One common defect of the open temple spread is a horizontal bend in the shaft. The solution to this is to heat and straighten the temple shaft using fingers or padded pliers. The next error in standard alignment of plastics frames is the open temple angle. The correct alignment has the temples at 90 to 95 degree angles from the frame front, and they should be symmetrical right to left. A defect includes open temple spread, lack of symmetry in the angles, or the temples are spread too narrow or too wide. The solution is to heat the end piece and use the thumb to push it in or push it on a flat surface if they're too wide. If they're too narrow, heat up the end piece and use the thumbs to push the angle back out. The next error that we're looking for in standard alignment is the flat surface touch. Place the frame upside down on a flat surface to see if there is any rocking. Then flip it over and see if there is any rocking. The correct alignment has no rocking when the frame is placed upside down or right side up on the flat surface. The frame should have approximately 8 to 10 degrees of pantoscopic tilt or angle. There should be no vertical bends in the shaft, and there should be equal lengths to bend. When we look at flat surface touch, the first defect we want to look for is vertical bend in the shaft. Looking at the temple shown in figure 8-26, you can see that instead of the shaft being straight, there is one bendward upwards. The solution to this would be to heat the area and straighten the temple. The next error to look for when examining flat surface touch is the defect of having the end pieces with unequal pantoscopic tilt or not the standard 8 to 10 degrees. The solution is to grasp the end piece and move the hinge, avoiding heat so you don't loosen it. Check lens insertion and correct if necessary. Check for bent hinge and correct if necessary. And check for bent end piece, correct if necessary. The next step in flat surface touch examination is to flip the frame over so that the temple ends should be touching the flat surface. If there is an unequal length to bend, then the temple tips will rock. Solution is to measure the length of the temple from the front to where the bend begins. It should be the same both right and left. Heat the temple, straighten, and rebend to equalize the bends if they are not the same. Now it's time to check the temple end piece angles. View the temples from the side and the top. With the correct alignment, each temple should have equal down bend angles of 45 degrees when looking from the side, and when looking from the top, the inward bends should be 5 degrees. A defect would be an inequality of down bend angle. The down bend of the right temple is not the same as the left, or the down bend is not 45 degrees. The solution is to heat the temple end piece and make both end pieces 45 degrees. The next defect would be the inward bend of the right or the left temple not being 5 degrees. The solution for that would be to heat the end piece and bend them until they're both 5 degrees inward. The downward bend again should be 45 degrees as shown on the slide. And the in bend as shown on this slide should be 5 degrees both right and left. You're almost done. The temple fold angle is the final step. The correct alignment should have the temples crossing centrally, superimposing each other when folded. The defect would be that the temples do not cross centrally, and the solution would be to use the hands or the angling pliers to move the temples up or down. Again, do not use heat for this step as you don't want to loosen the hinge. The last defect is that the frame would not fit into a standard case. If this is the situation, you must adjust the temple angles so they are not extending beyond the depth of the frame. Here you can see the difference between a frame that has the defect of the temples not being superimposed as compared to one that they superimpose. This slide shows a frame that has the temple end piece extending too far from the bottom of the lens, and the frame will not fit into a standard case. Congratulations, you finished a standard alignment of a plastic frame. Clean the lenses and frame before presenting them to me or putting them on the board. You should memorize these steps as you will be tested on them. Great work!